Hello guys, today we are going to talk about CBT question assigned by Dr. Halim. Let's check on the question. From the question, we can see that the question asks us to construct a life table that imitates the illustrative life table using interest rate of 5% and 6% per annum. In order to create an illustrative life table, we need debt rate data, and we can obtain death rate data from this website. Human mortality database. The country I chose is Hungary, and we can obtain the data from here. The death rate, the year. The data here indicates the year, age, gender, and the total death rate. We only need the total death rate of the year 2020. 2020 should be at the end of this page. You scroll all the way down, yeah, and we will need data from the age 0 to the age of 110. Let's look at the Excel I created. We will first start from the interest rate of 5%. We can see that from the table I created, we have the X, which is the age. This is the number of population who is alive. This is the death rate. This is APV of annuity, actual present value of annuity. This is whole life insurance. This is second moment of whole life insurance, and this is pure endowment. As we can see from the table, we have QX, which we obtained from the Human Mortality Database website of the country of Hungary, and we can get L1, which was LX plus 1 with this formula. With this formula, we can see that 1 minus QX equals to LX plus 1 divided by LX, and the whole thing times LX is equal to LX plus 1. So from here we can see that by using the formula of this, we can obtain LX plus 1. The next data we need to calculate is the actual present value of annuity. For every insurance, we need to make payment. Let's assume each year with payment of 1, as long as a person is alive. He need to pay for insurance. So here we can see that the person pay insurance at the year the insurance is purchased. For better understanding, we can see from the timeline here. The first year the person will pay 1. Let's assume the premium is 1. We need to pay 1 plus the second year 1 also, but discount. We need to discount the payment back to the first year with the person alive during the year. During the first year, 1P 0 plus 1V2. We need to discount at the second year. We need to discount, and then 2P0, and then do until infinity. For the table, we can obtain the APV of annuity with the formula 1 minus whole life insurance divide by the discount factor. We can know that the discount factor is 5ex. 5ex is a pure endowment. For better understanding, we draw timeline again. At the year of 5, if the person is alive, and then a benefit will pay to the person. Basically, pure endowment, when benefit is paid here, let's assume the benefit is 1. We need to discount it back to V5. You can see that the formula is V5, 5 year alive. If a person death occur here, pay nothing. The person will get nothing. The formula we can see here is V5 for the, and then 5px. Obtain the whole life insurance. We can use this formula. We factorize out the V as the constant as Vk plus 1, and then we left with Vk here, and Kpx, the person alive for K year, dies when the year of x plus K. From the formula, we can use the function sum product. I created a Vk here. The Vk indicate Vk power of 0, Vk power of 1, Vk power of 2. We use the function sum product to product the Qx plus K, Kpx, and Vk times the constant V. The constant V is equal to 1 over 1 plus I. The I we use here is 5%. For A1, which is Ax plus 1, the x here is 0. We can use the recursion formula. With recursion formula, Ax equal to Vqx plus Vpx, Ax plus 1. For a person, there's two situations, dead or alive. If the person dead, the probability is the death rate. If a person alive, the probability is the survival. So when a person alive, he will continue to have a whole life insurance benefit of Ax plus 1. Develop the probability of the formula using this equation. To calculate Ax plus 1, we have Ax here. We can use the formula Ax minus Vqx divided by Vpx equal to Ax plus 1. We have Ax here, we have V, we have Qx, x indicate the age. If we are looking for Ax plus 1, we have A0, then we can look for A1. If we have A1, we can look for A2. And we have Px here. Px is basically 1 minus Qx. N8 minus Vqx. V, we lock the cell here with the dollar sign. V Qx divide by V 1 minus Lx. 1 minus Lx is here. 1 minus Qx is equal to Px, which follow the formula here, and we can get Ax plus 1. And when we have ax plus 1 or ax, we can get APV of annuity of x with this formula. D is I over 1 plus I. The I we use here is 0.05. Okay, then we can obtain ax 1 minus n9 divided by d4 over 1 plus d4. d4 is equal to I, which is 0.05. We use the dollar sign to lock the cell. So when we drag down, we always refer back to the D4. Lock column, lock row. After that, we have pure endowment 5ex. Pure endowment formula is V 5 px. When a person alive here, and then we'll get the benefit. For pure endowment, we have E4, which is V, E4, which is V. Power of 5, and then 5px. We calculate 5px with this formula: 5 plus x divided by life when x, life surviving person, total surviving person at x. We divide for VP0. For VP0, we divide L5 over L0. For subsequent following the x, which is the age. Let's say for 5p6, we divide life when age 11 with life when age of 5, life surviving. Six. Complement of 10ex and 20ex, we do the same way as the 5ex, which the formula here is b power of 10, 10px, b power of 20, 20px. The person will get benefit when he alive. This is pure endowment. And then for the second moment of whole life insurance, we have this formula. Just follow the moment idea. We factorize out v square, and then we have v2k, sum of v2k kpx qx plus k. From here, we use the sum product function to sum kpx and qx plus k. With v2k, v2k here, we take y9 powered by 2. y9 is vk. And then we go for vk power 2. vk is v when k is 1, so v power 1. We get vk from here, v equal to 1 over 1 plus I power of k. After we have the column, we will get what exactly look like illustrative life table, but with the definite of country of Hungary. Next, we are going to construct life table commutation dx, nx, sx, cx, mx, and rx at interest rate of 5% and 6%. We will do it 5% first. We can see from the formula for the dx. Dx is the product of vx times lx. We have the vx here, which we calculated previously. Vx times lx. And then we just copy the formula for the rest of the table. For nx, mx is just summation of dx. We do the summation from n to the n to the n, the n. We log the cell of 118, which is the last cell here, so that nx sum all the value from x until the n. From sx, for sx is basically have the same function and formula with nx, which is sum of nx. For cx is a bit different. Cx formula is vx plus 1 times dx. Dx is the death occur during the year of x. We can calculate dx by subtracting lx minus lx plus 1. And then we have dx here by subtracting lx plus 1 with lx. And then we times it with yx plus 1, which is y9 x plus 1, because vx start with 0. If v x plus 1, that means start with v1. For c2, we have v2 plus 1 times with d2. C2, we have vx plus 1, which is v3, the blue box, times with d2, the red box. For mx has the similar formula as d and n, which is the summation of x, of area of it, and then r. For r, which is also similar with d, n, and m, which is the summation of m for r. After that, we need to calculate IAX, I annuity, increasing annuity, increasing whole life insurance, and EX. For increasing whole life insurance, IAX, we can get it using dividing RX and DX. Basically just divide RX and DX. And for increasing annuity at the time of X, we can obtain it by dividing Sx and dx. Basically, just divide Sx and dx, the blue column with the red column, with the red box. From here, we can obtain E0 by summing everything Kp0. By summing everything basically until the end, we have Kp0, we have Kpx here, Kpx here. We have sum everything, we can obtain Kpx from y minus Qx. After we sum everything, we obtain E0. To obtain Ex plus 1, which is E1, we can use the recursion formula. With the use of recursion formula, we note equal to Px1 plus Ex plus 1. You can get Ex plus 1 with this formula. Basically just back by 1 minus L8. L8 is Px. Minus 1, and then we get Ex plus 1. We just copy the formula until the end to obtain every of it. In order to get the life table with 6% annual rate, we can change this value into 0.06, which I duplicate the whole Excel sheet, and then I change the value with 0.06, which is the interest rate of 0.06, and we will obtain another data with the 6% annual rate interest rate. For the next question, I'm going to talk about question 4. On the question, we can see that we need to construct life table tabulating death rate, whole life insurance, APV of annuity, second moment of whole life insurance, increasing whole life insurance, increasing annuity, and EX for X. We can just simply duplicate the question 1 to question 4 and then hide some unnecessary information needed from X0 to 95. We can hide the age beyond 95 with the Excel hide function, and then change the interest rate into 0.07. From the question, we have a cumulative function of 1 minus bracket 1 minus x over 95 power of 1 over 6 from the x value 0 to 95. For better understanding, we are going to draw a timeline again. For a person dies at Tx, at the time of Tx, the death rate is the cumulative distribution function here. Person dies between 0 to Tx. We can calculate the probability using the cumulative function of f naught x. This function only applicable to a person who is in the age range up to 95 years. The limiting age is 95. We input the formula into here, and then we can calculate each year age probability of death. Next, we know that 1 minus f naught x equal to s naught x. This is the survival function. To get the survival function, we can just simply 1 minus fx the first question, determine the probability that a newborn will survive beyond age 20. By using this formula, 20p, note, you can draw a timeline. That means a newborn, which is at the age of 0, can survive beyond age of 20. Basically, this is just S naught 20. So we can just simply take S naught 20 here, 0.961368. For the next question, we need to determine the probability that a life age 25 dies before the age of 60. You can draw a timeline. At the age of 25, the person alive age 25 dies before 60. From 60 to 25, that's 35 years in between. The person need to die in between 35 years, which is 35Q25. We can obtain 35Q35 with 1 minus 35P25. 35P25, which is for 35P25, you can know that S naught X plus T divided by S naught X. This is TPX. So you can divide S naught 60 divided by S naught 25. For the next question, we need to determine the probability that a life age 35 dies between 50 to 60. For better understanding, draw a timeline. For age of 35, 50, 60. We can see that the person need to die between this age range. We can write in the actuarial notation, the person alive for 15 years, 15 deferred, alive for 15 years, and then die between 50 to 60. 10Q35. This is death, this is alive. We can break this down into the person alive for 15 years, and then death at this year at the 10-year age range. For 15P35, we can obtain it with L35 plus 15 divided by L35, which is L50 divided by L35. And then for 10Q50, we can do it 1 minus 10P50, which is 1 minus L60 or L50. From these two equations here, we can conclude it. This is S naught 50 divided by S naught 35, and then from here we can see that it's 1 minus S naught 60 divided by S naught 50. After we obtain these two values, we times it together, and then we will get a probability of 0.0391% of a life age 35 dies between age 50 and 60. This is the end of the question, I think. Thank you for listening.